Alright, question 2. We've got 6 coins tossed and the number of heads is recorded, so this is binomial. Student wishes to compare the results with theoretical predictions. So let's make some theoretical predictions. So the number of ways we get 0 heads is, well, there's only one way because that's 6C0. We're doing it 6 times and we want 0 heads. The number of ways we can get 1 head, 6C1, so that's 6. The number of ways we can get 2 heads, 6C2, so that's 12. Instead of asking, why didn't I just chuck it in my calculator? It's 15, gosh. Okay, 20, 15, 6, 1 for a total of 64. Then if we want to read off the most common result, the most common result is the one that can happen the most times. So it's going to be 3, because that can happen 20 times. So everything is like 15 times or 6 times or 1 time. So the 3 is probably going to be the most common. Question C, use this table to determine the expected value and variance. Okay, so the expected value is the sum of x times p x equals x. So essentially this is the sum of the number of heads times the probability that we're going to get that number of heads. So we're going to have, well, we're going to add all these together. So we've got 0 heads times the probability of 0 heads, which was 1 times 1/2 to the 0 times 1/2 to the 6, plus, and then we've got 1 head times the probability of getting 1 head, so 6 times 1/2 to the 1 times 1/2 to the 5, plus, now I'm just going to make my life easier. Notice how all this bit and for the next one will be the same. Will always be 1/2 to the 6, which is 64. Yep. I'm going to take that 1 on 64 out the front. So I've got 0 times 1 plus 1 times 6 plus 2 times 15 plus 3 times 20, 4 times 15, 5 times 6, 6 times 1. So let's get this. I've got 1 on 64 times 1 times 6 plus 2 times 15 plus 4 times 15 plus 5 times 6 plus 6 times 1. 192. So that comes out as 3. Let me double check that. Yeah, okay. Now the variance is, what was the formula for the variance again? Let me check the textbook. The expected value of x squared minus the expected value of x squared. So the expected value of x squared is, the same as, what's the value of x? Oh, okay, so we're squaring these ones. So this one's going to be 1 on 64 times 0 squared times 1 plus 1 squared times 6 plus 2 squared times 15 plus 3 squared times 20 plus 4 squared times 15 plus 5 squared times 6 plus 6 squared times 1. And then we're minusing off the square of our expected value, which was 3. So this one comes out as 1 on 64 times 1 squared times 6 plus 2 squared times 15 plus 3 squared times 20 plus 4 times 672 minus 9. So that comes out as 1.5. Which incidentally means the standard deviation would have been square root of 1.5, but they haven't asked that. Okay, question D, obtain that by, figure that out by using the two formula. Yeah, it's so much easier with the formulas, and you will never do it by adding and subtracting unless they're really mean. Okay, so we've got mu equals NP, which is the expected value, which is going to be, we did 64, wait, no, 6 fair coins. So we've got 6 times half, which was 3, what a surprise, and the variance, NPQ, so this time it's going to be 6 times a half, which is 1.5. Oh, I love the formulas. And E, explain why, in your own words, why the result for the expected value is not a surprise. I mean, it's a fair coin, and you're going to get heads half the time, and half of 6 is 3. So why? Yeah, that's not a surprise. Yeah, half of 6 is 3.